All right, so welcome back. Welcome back to this channel. So, in this video, as you have read the title and the thumbnail, we are going to learn. I think two clustering algorithms. We are going to learn about two clustering algorithms. This time, the word "we," right? We are going to learn clustering algorithms because even I do not have that much idea of these algorithms, right? I think I have in this channel, we have been focusing a lot about deep learning and the latest deep learning architectures and all the latest deep learning problems that we are solving. But we haven't covered the machine learning, the classical things, which are I think pretty important. The foundations are pretty important. So we'll be covering. I think I'll try to cover some machine learning algorithms also in the process. So in this channel, we are not only going to upload deep learning, but also going to cover some old and classic machine learning algorithms, which are, I think, just good for intuition, just good for learning intuition. And more importantly, I think pretty ironically, deep learning is actually solving some of these problems. Right? Some of these problems can also be solved with deep learning, but just because these algorithms are like classic and maybe some may ask you in these interviews, maybe if you are going for an interview, these algorithms might be asked because these algorithms are the most famous ones, right? Machine learning algorithms are the most famous one. So therefore it's just good to know. Maybe you just come to a problem, maybe you want to solve a problem, and sometimes it is, maybe you want to use machine learning algorithms in that case. So therefore, it's just good to have a knowledge or a lot of algorithms. So therefore, we'll be learning some ML algorithms also in the process. But still, most of the problems that we are solving in the field of AI uh, is in the field of deep learning. Right? Just like a note. So I'm opening the whiteboard. And as I've told you, and like I do have some idea of what that is, and also we'll be, I think, we'll be just using the online resources to learn together, because that's the best thing I think, right? So whenever I come across, let's say a new algorithm, I'll just do this, and I will go through the process of what I will do, and this process is actually very fast. You don't have to spend lot of hours. Of course, you have to in order to be good at it and maybe get a lot of deeper understanding. But in this video also, I'm going to do like a fast run of how you do it. This video is a very shortened version of all the preparation that you have to do in order to understand the algorithm. But in the real life, when you are learning a new algorithm, just make sure you spend more time with studying and using and playing around with different maybe resources related to the algorithm, right? Found on the internet. So clustering algorithms. First of all, I'll just see what clustering actually is. Let's just go through the internet and just find some resources to learn about clustering. Again, this is not a how-to video or how a teaching video. It's just a video where we learn together, which is I think pretty fast and also I think pretty productive. I also think let's open ChatGPT, because recently um, this has been helping me through a lot of things while learning a lot of things, right? um so let's just search what is clustering. I'll search what is clustering. Clustering is a machine learning and data analysis technique used to group similar data points together based on their inherent characteristics or features. The primary goal of clustering is to identify patterns and structures within a data by organizing data into clusters of groups so that data points with the same cluster are more similar to each other than those in other cluster. Right. Some points clustering is typically an unsupervised learning technique, meaning it doesn't require labeled data. Instead, it relies on inherent structure of the data to group similar items together. Right. The clustering is basically given some data points. We'll be trying to group this data. Sorry. So we're trying to group this data into let's say we have let's say we have two-dimensional data. Right, just for visualization case, just for simple visualization. right? Let's say we have some two-dimensional data. Sorry. Right? Let's say we have some bunch of points. And let's say these are data points. Or no, let's say these are like, let me just say something like, yeah, let's say age and height, relation between age and height. So this is age, right? As this is like 0, 1, 2, and so on. This is also 0, 1, and so on. Right? So lesser the age, the lesser the height, the higher the age, the higher the height. So therefore, given some data points, we have been given some data points. Clustering is the problem of identifying these two separate groups, right? Just differentiating between these two data points and just able to segregate them into some type of boxes, just trying to understand the difference between them. And here we will not be given the label, right? We are just given the X, right? In normal deep learning and other supervised learning algorithms, we will be given X and Y, right? Here this is like X1 and X2. So these are like two features, X1 and X2, and we are just able to, right? We are just able to segregate these data points into two separate groups, right? So that is having clustering in a very I know that is clustering. And you can have data of, let's say, higher dimensions, higher maybe with higher amount of features, right? X1, X2, X3, and so on. And we should be able to identify the distance and trying to able to segregate them into two separate, just try to differentiate them. That is the basic idea of clustering algorithms. Right, so that is clustering. And in this video, I think we're just going to cover like some basic clustering algorithms. So I think two basic clustering algorithms, because I don't want to make these videos too long. So the first one is, I think we'll just go in KNN algorithm. KNN clustering is actually pretty simple, and this might be a little different from what we have seen from ChatGPT. So this is not a unsupervised learning task, KNN. This algorithm solves a supervised learning task, a supervised learning classifier, which is just proximity. And this also, if you after hearing this algorithm, you might not believe that this is machine learning algorithm. Yes, this is probably not a machine learning algorithm, because this doesn't use any type of like optimization or any type of parameters or something, right? There's no parameters that that will change over time or something. There's nothing actually. And also these are just like some algorithms, right? When I say algorithm, I mean algorithms that you see in like software development. Let's say you have maybe like something like the data successful algorithms, right? Let's say if you are a software developer, you learn something about DSA. I think you could consider these algorithms also in that category. These are just like simple, not simple. I mean, we cannot define whether they're simple or not, but these are simple algorithms that you just carry out in a very straightforward process. You don't have any magic such as gradient descent. Like gradient descent is the whole magic of neural networks. You don't have that type of magic or something. Just I think pretty straightforward, right? We'll just cover what KNN is. I have a little idea of what that is. I'll just share it with you. Right. So the basic idea of KNN, pretty simple actually. So here, first we'll formulate the problem what we are solving. So here we'll be given, let's say, yeah. So I think we'll be given two types of data. Right, we'll be given two data. Right. I think let's say this is two groups of data. We are given two groups of data, and this is some type of data. We will not consider what I actually mean, but let's say we are given some data like this. Let's say two groups, right? Now what we'll be doing is we'll be given some new let's say some new data point such as this. It will be given a new data point like this, and the idea is that right? So that the main problem that we'll be solving here is we will be able to we'll try to formulate, we'll try to figure out where like to which group does this data point belong to, right? To which group does this data point belong to? So that is a question that we'll be solving. And how could we, right? So actually a pretty straightforward approach, right? We will just get like the nearest points, right? What are near. So let's say we have so we'll be having a variable called n, right? So while running this algorithm, you will be setting a value of n. So let's say I set the value of n to be 2, right? So we are going to get the two nearest points, right? So this is one nearest, let's say this is the first nearest point and this is the second nearest point. So we'll be getting the two nearest points, and whatever these points actually are, we are going to make this point into that group. So now this is going to be this, right? This is going to change into this. So essentially, so I'll just change that. So if n is equal to 2, we'll take the two nearest let's say points. We'll take the two nearest points, and then we'll just give it the class that it holds. So let's say I set n to be something like, let's say 5. Then it is, let's say, going to take this also, and then maybe also take this. Maybe this is the next nearest thing, and maybe this is not the next another thing. Right now, what we are going to do, right? We have the nearest neighbors. So these are the nearest neighbors, the nearest points to this data point. So the nearest data points are this, and this, and this. And whatever has the highest votes, like whatever have the highest number of, let's say, like whatever is the nearest and whatever data point is near to it, the highest number and the most recurring number of times, that is going to be the feature of this point, right? So that therefore this is going to be a star mark sign. Pretty simple, right? Pretty simple, right? So this is the algorithm KNN, right? Given, let's say now, right? So let's say now we are given another point here, exactly in the middle. Now, right? Maybe we get a draw or something. Like in most cases, I think we'll just select a odd number just to make sure that there is no draw. And maybe we are trying to group data. So this is the basic idea of KNN. And the same, and just like this, you can have as many classes as you want. Here you only have 2 groups or 2 classes, and you can have as many classes as you actually want. Right? Let's say we have let's say squares. So these are pretty diversified or something. Right? Then you could have actually as many classes as you want, and just simply we'll just get the nearest neighbors of that specific point using simple software development, maybe using algorithms such as Euclidean distance or something, or Manhattan distance or Minkowski distance. You know that, you know it, right? So we'll be using distances like this to figure out the distance between these 2 points, no matter how high, no matter what dimension these vectors belong to. Now we have drawn it in like 2-dimensional, just for the simplicity of visualization. You could have this vector to be as dimensional, as higher dimensional as possible, and you could just use the nearest value. So you can just use simple, like let's say a for loop, and just loop through the nearest values, or maybe have a for loop that goes through all the points with respect to the current point and just find the distances from the current point to the let's say every point, and maybe you could just sort them out and do that. So that you can do that. Let me just go through some code very fastly. Let's say from scratch. Again, I think I'm going to get copyrighted or something. Maybe they're going to give me some copyright. I don't know, maybe because I'm just using these resources. I mean, I actually thought of building this from scratch by my own, but just figured out that they are not like worth the time and effort given. So I think I'll just that, right? So let's just go to the final example. They have provided the code here, and give an example or something. Right. So here we are given the code. Right, let's just try to understand what this actually represents. I think we can add delete indentation. We can add indentation, like correct indentation, like in a code format. This is actually pretty good, right? And so I think we'll just go through the algorithm, what it actually. Now let's just understand the algorithm again. So we'll just skip the data pre-processing parts because I think this is applied to some data set. Let's just I think iris data set. And again, this resource, this website is a very good website, Machine Learning Mastery. I mean, I don't actually remember the name, but I have been using it for a very long time. Yeah, so I think this is the main part that we have to carry about. Right. So first, I think we are going to use the Euclidean distance. We are going to use a function called Euclidean distance. So this is the main function. Pretty simple, right? So first of all, in the function, the inputs of the function are train. So train is nothing but these outputs. So these values, right? These values belonging to specific classes. So we're going to have these vectors and their class. So whatever class they belong to, right? And then so that is train, and then test row. Here test row is nothing but the new point that you have been given. So let's say we are given a new point. So the new points will be given. So we'll be given some new points, right? So these are test rows. So these are test examples. That means they haven't yet been classified. The train is the classified data that we already have. And the number of neighbors is nothing but the variable n, which defines the number of neighbors that, in the surroundings that we have to take into fact, right? And then this actually plays a very huge role in like selecting number of neighbors anyway. So we'll just first initialize a list called distances, and we'll just loop through the train list, right? And then we'll calculate the distance between test row, right? We'll just calculate the distance between these dots and so we'll just loop through all these data points. We'll loop through all these data points using this for loop, right? We'll loop through all these data points and we'll just calculate the distance of each point, right? We'll just calculate the distance of each point from this thing. So let's calculate the distances from each point to the test point that we have been given, and we'll just append this in distances to a list, right? We'll just append this distances of each data point. Sorry, my bad. And then we'll just sort this up and just do some data processing. I think we'll just create something called so what we are going to do is we're just going to get this tuple and get the first value, and we're going to sort it. We're going to sort it in the least to highest number. So yeah, so we are going to get the second value, which is the distances. So we are essentially going to sort these distances. We are going to arrange them in ascending order, right? From we are going to sort them in ascending order from smallest distance to highest distance, and then based on the number of neighbors, let's say we can even 5 number of neighbors. So we will get the first 5 or first n number of nearest neighbors, and as this list is sorted, we'll get the nearest neighbors only, and then we'll just return the neighbors. So that is the basic idea. That's the KNN algorithm. Now let's go to the next one. K means clustering. So here we are. Here this is unsupervised learning task. K means is a supervised learning task, right? But here this is an unsupervised learning task. So again, given let's say a 2-dimensional space in which we have data points. So let's say we are given some data points. Right? I'll just draw this term in a specific other manner. Maybe maintain some distance just to make sure it is clear for us to understand and make it easier for me to draw. Right? All right. So let's say this is the data, right? And then we want to make 2 groups. So let's keep another variable, just like we did previously. Let's see, we have 2 here. G is equals to. So G is nothing but the number of groups you want to cluster this data into. So we want two groups. So we want to essentially classify this data into two separate groups. For doing that, we'll create something called centroids. So centroids is nothing but just like some pointers. Think of some pointers. So we'll have some random pointers. And we'll just take these pointers, two pointers, and we'll just plug them into this two-dimensional place. I don't think plug is a very good word. I'm bad at grammar, I know. So we'll just take these two centroids, right, and just put them up. And I know, let's just see what it means. So I even, like, as I told you, I don't remember any of the details. So therefore, for the details at least, like all the mathematical operations in details, I do have the main thing, but yeah, let's. Yeah. So essentially, we will have two centroids, right? And we'll just put these centroids in this two-dimensional space, and then simply we'll just loop through all these points. We'll just loop through all these points just like we did previously. We'll just loop through all these points, and then we'll just get the Euclidean distance between each point to both of these clusters. Right? We'll just like that. We'll just get the Euclidean distance. I'll remove the arrows just for understanding. So we'll just clarify the Euclidean distance, the distance between these two centroids with respect to each point, and then we'll just assign all these points to that specific cluster. Right? So all these points here. So let's say this is the R, this is Y. So let's say this is red and this is yellow in color. Right? Just because I cannot add color, I'll just put R and Y here. So let's say one group belong to red and other group belong to Y. So here, all these points are going to be R. Right? Maybe this is going to be Y. Maybe this is going to be Y, because maybe this is closer than this. Maybe, right? And then maybe this also is going to be, let's say this is going to be Y. This is another point. This is going to be Y. And then this is going to be R. All these are going to be R. And all these are going to be Y because theoretically they're closer. Right? All these are Y. Anyway, I can draw. Right. So all these are white, right? But still we have some outliers, and maybe then taken in a very different manner. When we're initializing the centroids, if they are taken in a very different manner, we could have many misconceptions. That here, as you can see here, as R and Y are closer, we have some Y values here in the R group, which is not good. So after calculating these centroids, after assigning each centroid to the after assigning each point to its nearest centroid, what we'll be doing is we'll be just calculating the mean of the positions. So essentially, let's say we have two-dimensional X and Y. So each point is going to be X and Y. So here Y doesn't mean, okay, I'll just use X1. So X and X1. So this X and this is X and this is X1. So each point is going to have a coordinate X and X1. So therefore, so what we'll be doing is we'll be just calculating the mean position. We'll be calculating the mean X and mean X1 for each centroid. So for, let's say, for all the Y, for all the yellow points, for all the points that belong to the yellow centroid, what we'll be doing is we'll be calculating the median. We'll be calculating the mean position. And after that, after calculating the mean, we'll place the centroid in the mean position. After calculating the mean, let's say the mean is this. Centroid is going to stay here. And for red, let's say, right, for red, the mean position is going to be somewhere around here. So after that, after calculating the mean and placing them in their mean positions, we are going to calculate the distance of each point to the centroid again. Right? Now what we are going to do is, now what is going to happen is, these misclassified yellow, so these misclassified points such as this and this are going to come back to red, because red is closer and Y is longer, yellow is longer. And this is actually pretty neat algorithm, right? Pretty intuitional and pretty good, right? And I think pretty better algorithm as we have converged in very small steps, right? So this is k-means clustering, and even with maybe messy data also, you could just get to the optimal position in just like a few iterations. So that is k-means clustering. Right now, I think we'll just go through the code very fastly. Now we'll just go through the code very fastly. We'll just try to understand what. No, but I know, but just by looking at the code, we can understand everything faster. Towards data science. Yeah, so this is algorithm. So essentially, the fit function, we will be creating class here. So we have max iterations, the number of iterations we have to do, the number of clusters we have, number of groups we want to create, a number of clusters and number of groups are equal. So in the fit function, this is the main function. We will calculate the mean and the max, the minimum point and the maximum points, I think. And then we are going to place these centroids, I think, in a very centroid equals to uniform means plus max. Uniform, what is this uniform function? Uniform max for in, so we just group. Okay, so we're going to have a number of clusters, right? And we're going to have number of clusters, and I just skip this step. I think we're going to create some number of clusters, n number of clusters, and we're just going to place them for the first step. I think that's the first step. After that, we're going to have iteration equals 0, and we're going to have a while loop here. We're just going to, just like a for loop, and so we'll just loop through the number of iterations. So we're going to have the number of iterations, right? Number of iterations. We have to form this K means algorithm. We're going to perform this K means algorithm, and then we're just going to sort this. So we're going to create a list called sorted points, in which we are just going to loop through all these clusters and just get all, yeah, we're going to have like bunch of list, I think, and we're just going to have G number of lists or n clusters number of lists. We are going to loop through X train, which is I think all the points, right? All the points that we already have, and then we're going to calculate the distance of each X of, or so we are going to calculate the distance of each point with respect to each centroid, right? With the number of centroids, we're going to calculate the distance of the point with the centroid, and then we are going to get the so essentially we are going to get let's just see what our argument does. np.argument minimum values returns indices of the minimal values along an axis. Okay, so I think, yeah. So essentially we are going to get the minimum value. So given these distances, we are just going to get the closer values, right? So let's say 2 values are closest, or for each point we are going to get this closest centroid, right? Whatever centroid that is, and for that point we are going to add that centroid index, right? So each centroid is going to have an index. So each centroid is actually represented by an index, and then each point is assigned with that centroid number. And after doing that, after calculating the distances, what we are going to do is we are just going to calculate the mean of centroids for each cluster. So for each for each cluster we're going to have a separate centroid, right? So we're just going to calculate the mean of each centroid, and we are just going to we're just going to change these centroids, right? We're just going to change these values. So we're just going to change these values into their mean positions, right? So simply we have looked at the algorithm, and this is the basic clustering algorithm that you should know. So I think you have found this pretty informative. Maybe the coding part, maybe the reading the code part is not very good. So thank you for watching. I hope you understand clustering. I hope you find this valuable. So thank you for watching. I'll see you in the next one.